Hi everybody, we are going to talk about graphing quadratic equations in this video. This topic is not in EdReady, so it's not going to be in your study path, which is why that's there. So the information you're going to need for this topic is going to be located in your notes, and we're going to be working on just talking about different characteristics and qualities about quadratic equations and what their graphs look like. And then we're going to work on graphing them, and we're going to do several examples, just practicing that skill. All right. The other thing I want to tell you is that this tends to be a little overwhelming at first because it is a lot of information. So I just want you to hang in there and just keep going back to your notes, referring to your notes as we're working through these examples. And I promise with some practice, it gets a whole bunch easier. All right, so for a graph, we're looking at characteristics of graphs of quadratic equations. Remember again that a quadratic equation is going to be of the form ax squared plus bx plus c equals 0. So again, remember that's our standard form. A quadratic, the highest power on that equation is going to be 2. And so again, that's what the quadratic equation means. So a graph of a quadratic function is going to be a parabola. And a parabola is a cup-shaped curve. Cup-shaped curve. Ooh, maybe I can fit that in there. Okay. So a cup-shaped curve that's either going to open up or it's going to open down. So it's either going to look like this or it's going to look like that. So for our quadratic equation, we're just going to look at 2 different equations, and then we're just going to kind of break down the characteristics that we can pull from the equation. So let's say we've got this one. We've got y equals ax squared plus bx plus c. And then our other one is going to be where the a value is negative. So if we've got y equals negative ax squared plus bx plus c. So really the quality that I'm wanting you to kind of focus on is the fact that, this a is going to be positive on the left. And then for the right column, the a is going to be negative. And so I give you an example of what that might look like here and here. So if a, now I'm looking over here at this second row, if a is going to be greater than 0, so that means if it's positive. So if a is positive, and you might write that in, circle a greater than 0, that means positive. So if a is greater than 0, the parabola is going to open up. If a is less than 0, the parabola is going to open down. So in our situation for this box, we're going to be looking at this equation. So in this equation, a is equal to what? What's the coefficient of our x squared term? And I'm hoping you're saying 1. So the parabola is going to open up. So it's going to open like this. On this one, our a is equal to -2. So the parabola is going to open down. So the next piece that we can pull from the equation is going to be our vertex. So the vertex is also called the turning point. So it's called the turning point of the parabola. It's a single point on a graph. So what that means is, for example, if we have this, and I talk about the turning point. So if I put my, pencil on this portion, I go up, 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 and then all of a sudden I start going down, down, down. The vertex is going to be a single point right up here, where all of a sudden first your graph is increasing, increasing, increasing. Now we're decreasing, decreasing, decreasing. And so your vertex is what's called the turning point of your graph. And it's a single point. It's not going to be more than a single point. So what I'm going to tell you for this graph is that they've already figured out the vertex for you. So it's just given to you. So this is just given that 1, -4 is going to be your vertex, and then the other one, -1 3/4, and 10 and 8 and 8 is going to be your vertex of that parabola. We are going to work on calculating that today, but there's no way for you to just look at the standard form, the standard form of the equation to just pull that information out. So don't worry about pulling that out yet. We're going to calculate that later today. The next piece that I want you to look at, it's going to be the minimum the minimum or maximum point occurs at the vertex. So 1, -4, think about this. If 1, -4 for this parabola is right here, 1, -4, and then this one over here, we've got -1 3/4 and 10 1/8. So on my first example, the 1, -4, is that going to be your minimum or your maximum point? It's going to be the lowest point, so it's the minimum or the lowest point on the graph. Conversely, if we look over here at the other parabola in the example, the vertex on this one's going to be the maximum or the highest point on the graph. So we're just kind of talking about our different terms that we can use to describe our parabolas. All right, so our next characteristic, we can talk about the axis of symmetry. So the axis of symmetry is a vertical line that intersects the parabola at the vertex. And the parabola is symmetrical about this vertical line. So for example, on our parabola that looks like this, where we've got 1, -4 here, then our axis of symmetry here is going to go right through this, like that. And it's not like, it's just a characteristic of our graph. So when we're graphing it, that's why I put it as a dashed line, because it's just an axis of symmetry. So it's not like, if I go graph that equation that was given at the beginning of the problem, when I go graph it, like even if I use a different graphing calculator, the axis of symmetry isn't just going to show up. It's just a characteristic of our graph. So what's great about it is that if I find out what this point is, I know that this point here, and I'm just going to call that A, I know that point A is going to reflect over here because it's symmetrical to be my A prime. And so it's really helpful because when we're getting ready to go graph these, what that means is that we can actually find a point on our parabola, and then we can just reflect it across our axis of symmetry in order to graph another point. So maybe this point's B, and this point over here would be B prime. And so we're just reflecting it over. Okay, so that means for ours, the graph of x equals 1, right? It's a vertical line through 1. Is the axis of symmetry. So that means for over here, we get x equals -1 3/4 for our axis of symmetry over here, because that means, again, we've got our axis of symmetry as a vertical line going through x equals -1 3/4. So then the last kind of characteristic we've got, it's going to be a root. So a root of the parabola is where the curve intersects the x-axis, also known as an x-intercept. And so this one, our parabola has 2 roots at 3, 0 and -1, 0. And on this one, we've got -4, 0 and 1/2, 0. So if we're just doing like a really quick sketch of this, what I would do is note the fact that we've got our vertex at 1, -4. So I'm going to put that here. And then we know that one root is going to be at 3, 0. And the other one is going to be at -1, 0. We know it's opening up. So we've got that. And we know that our axis of symmetry goes through x equals 1 for that. Then for our other problem, to remember what our vertex is, so we've also got the point to graph -1 3/4 and 10 1/8. So here for my graph, I've got -1 3/4 So I'm going to put that almost at 2 all the way up to like 10 and an eighth. And I'm just going to label that as -1 3/4 and 10 and an eighth. And then we are going to be putting the other point at -4, 0 and 1/2, 0. And so then we graph our parabolic curve like that. When you're graphing, make sure that you're not doing like a V shape like that or a mountain, like a pointy. Don't do that. So what those are, these are actually absolute value functions, not parabolic curves. So these are absolute values, like if we were to go graph those functions, and we don't want to graph those. So don't draw that. Draw a nice curve for your vertex, not a point. All right, next sketch. I kind of already talked about this when we talked about discriminants a few lessons ago, but this is just, remember this information from when we talked about it. So there can be a situation where we have 2 roots, 1 root, or no roots. And we're going to sketch those scenarios below. So remember what a root is. A root is just an x-intercept. So we can have 2 x-intercepts, we can have 1 x-intercept, we can have no x-intercepts. So I'm hoping you remember way back when talking about discriminants, right? That's the information, or that's the number that you're going to get underneath the radical. And when we were looking at this, we were looking at situations where the discriminant is going to be positive, where it's going to equal to 0, and where it's negative. And in the first situation of positive, I don't know if you remember this, we said that we would get 2 real solutions. And then when it's equal to 0, because remember, it would be like plus or minus that number, and this one's going to be plus or minus that number. So plus or minus 0 is just going to be the same answer. So this is where we get 1 root, and it was 1 real root, or 1 real solution is actually what we were calling it then. So 1 real solution. And then if it was negative, we got 2 imaginary solutions. And so remember, 2 imaginary solutions. Can I actually graph an imaginary solution on my 2-dimensional real number system grid? No, I can't. So when I get a negative underneath the radical, I'm not going to have any x-intercepts. So the 2 imaginary solutions means no x-intercepts. So what does that mean for our graph? Well, I'm going to draw up 3 grids quick. And so this one, maybe this is our 2 roots situation. So we could have something like that. We could have something like this, where we're getting 2 roots. And so again, what this means is that underneath the discriminant, it's a positive number, and you're getting 2 roots. For our next one, what it means is that the vertex is going to be intersecting the x-axis. So it could be something like that. And so this is going to be, again, when underneath the radical is a 0, and you get 1 root. So 1 x-intercept. What I'm also hoping you notice is that this is the vertex, right? So when we get to the situation and we get a 0 underneath the radical, that should help you in your process to identify that, or to realize that our vertex, when we find our vertex, is also going to be our root. And so that's going to help streamline your process some. Then for our next one, if we have no x-intercepts, it might look like this. So this is going to be where we get a negative underneath the radical, and we have no roots, or no x-intercepts, if you prefer to say that. All right. So now we're going to talk about our steps for graphing, and then we're going to go graph these guys. So for the first step, what I want you to do is that you're going to determine whether the parabola is going to open up or whether it's going to open down. And so if A is positive, or if A is greater than 0, then the parabola is going to open up. If A is less than 0 or A is negative, the parabola is going to open down. Then we are going to find the roots, or the x-intercepts. if they exist by factoring, which we really didn't work on really at all. So we're probably not going to use factoring too much here. Square root property. Or quadratic formula. Typically for this class, what I show you is we're going to either work with square root property or quadratic formula. So we'll use one of those two methods. Next, we're going to find the axis of symmetry. And how do we do that? We use the formula of x equals negative b over 2a. So that is going to be our axis of symmetry. Our axis of symmetry is going to take the coefficient of your x term, which is b, put it over 2a. A is the coefficient of your x squared term, and it's going to be negative. So then we've got, this is also going to be the x value of your vertex, right? That makes sense because we know that our axis of symmetry goes through our vertex, right? And so that means that the x value of our vertex is also going to be the x, like let's say this is at 2. It's also going to be, you know, x equals 2 is the equation of our vertical line for the axis of symmetry. Well, that x equals 2 is going to be the x value of our vertex. Why do we care about that? Because then we're going to use it to find the y coordinate of our vertex. So we're going to find the y coordinate of the vertex by substituting the value of x into the original equation. And then we get out the y value. And then we're going to plot that ordered pair. And that's what we're going to say, plot the ordered pair. If you've ever looked at function notation, the function notation would look something like this. If we said negative b over 2a, and then we would say f of negative b over 2a. If that doesn't make sense to you, don't worry about that right now. But those of you that have looked at function notation before, that's what we're doing in that process. All right. Then for step number 5, find 2 or more points. So find 2 or more points or ordered pairs by picking and substituting 2 values of x into the original equation that are near the vertex, but that are not the roots. Well, what the heck does that mean? What that means, I'm going to draw a little graph down here. So let's say we've got our vertex, and our vertex is going to be at like, I don't know, like 1, 5. So I'm just going to say, let's just pretend that that's at 1, 5. And so let's say we've got a vertex over here, and we'll call this -1, 0. And then let's say we've got our other one over here at 3, 0. And I said, okay, well, I need you to find one more point on our parabola, and then I need you to reflect it over, because we have it to have a minimum of 5 points in order to graph our parabola. So what I would tell you is to say, okay, well, look at the x values that we've already used. We've used x equals -1. We've used x equals 1. We've used x equals 3. So what's another x value we can use that's not a root and that's close to the vertex? And I'm hoping you say, oh, look, we could do x equals 0, and we could do x equals 2, and you would be correct. And what I would tell you is that your x equals 0 is going to be so easy. So we should plug in x equals 0, find out what that is, and then we would reflect it over across the axis of symmetry in order to get us 5 points. So that's going to be our process today. All right, so then for step number 6, we're going to plot the information we would have just found, and we should have at least 5 points on your graph. So we need 5 points. Then we're going to draw a smooth curve right? We're not making it look pointy like an absolute value curve. You're making it look smooth. And then you're going to check your value of A to make sure that your parabola opens up in the correct direction. So what that means is at the very end, we're graphing our parabola and you said, okay, look at this, it's opening down, which means my A should have been negative. And so you should look back and say, did I have a negative A? Because if I didn't, then I've done something wrong in my process to find my parabola. All right, so now we are gonna put all these steps into action. So what I'm gonna tell you to do is to keep this page handy, like maybe pull it out of your notebook for a second. And then if I recall, I can't remember if 60 and 61 are like front back with each other. If they are front back with each other, what I want you to do is keep your steps handy and then move to the next set of graphs. So that way you can be looking at your steps and then also looking at two graphs, okay? So again, I'm wanting you to separate your notes out so that you're looking at the steps as you're looking at our two graphs. And you really need to be just like engaging as we're going through this video and not just following along like a lemming, because it's not going to make sense if you're not like actively kind of asking your brain, what should the next step be? What's the next process? Okay. All right, so I am going to give you a function here, and then we're going to walk through those steps. And I'm going to keep my steps handy too so that I don't forget the process that we're in. Sometimes I skip steps, and I don't want to do that today. So let's look at this. The first one I want you to try, the equation that I'm going to give you is going to be x equals 4 x squared minus 8x equals y. So that's going to be the first equation we're going to look at. So that first step, I want you to look back at your notes. This would be on page 60. You're looking at your notes and we're saying, what's the first one? And I guess I'll just number it again. So my A is positive, which means my parabola is going to open up. Step 2, we are finding the roots. Find the roots. Or find your x-intercepts, right? So on this one, what we're looking at is, can we do the square root property or can we do quadratic formula? The square root property only works when we just have like an x squared term, so we don't have an x term. Well, that's not the case that we have. Excuse me. So we're going to use quadratic formula. So let's go back to those steps. And it's going to be 4x squared minus 8x. I'm going to write plus 0 in there to be my space holder for a c equals 0. So then my a equals 4, my b equals negative 8, and my c equals 0. So now I am ready. I was hurting my wrist. Okay. So now I'm ready to plug this into my quadratic formula, and I've got negative 8 plus or minus the square root of negative 8 squared minus 4 times a times our c all over 2a. Did anybody look up those videos that I told you to look up that are the songs for the quadratic formula? Negative b plus or minus the square root of b squared minus 4ac all over 2a. I'd sing the One Direction song for you, but I don't remember how it goes. Sorry, you're gonna have to look that one up. Trying to think if I can think of it. No, it's gone. I don't have it. I'm gonna have to play it for you one of these days though. All right. All right, so we've got positive 8. We're gonna have 64 minus 0 all over 8. Then we're gonna have 8 plus or minus. So the square root of 64 minus 0, right? It's just gonna be square root of 64. And the square root of 64 is just 8. So that's what I'm gonna put here, all over 8. So now I've got two answers, right? So again, look back here. We've got a positive underneath the radical, which means we're going to have 2 roots. So then we're going to have 8 plus 8 over 8. So 16 over 8 is going to give us 2. And then we've got 8 minus 8 over 8. So that's going to be 0 over 8, which is 0, which means our other ordered pair is going to be at the origin of 0, 0. All right. So what I want you to do is go plot those 2 points, 2, 0, and 0, 0. Then step number 3. What does it say we're doing? We're finding the axis of symmetry. Axis of symmetry is going to be x equals negative b over 2a. Well, check it out, right? This first part, if you go back to your quadratic formula, this negative b over 2a is right here, right? That's that part of the quadratic formula. And so if you want to, you can just look at it right here. It's this portion. So what that means is that it's going to be x equals, and if you wanted to, you could go ahead and do negative 8 over 2 times 4, which is going to be 8 over 8, which equals 1. All right, so that's our axis of symmetry. So we're going to go put that on our grid. This is also the x value of my vertex. So I'm going to take that x equals 1 and I'm going to plug it back into my original equation in order to get out the y value. This is kind of like the table method, right? So think about like step number 4 being like, and it'll be step number 4 and 5 where you're using kind of like a table method. So for example, like this, I just want to show you real fast. 4x squared minus 8x. 4x squared minus 8x. So if we did something like this and then the ordered pair, just like what we were doing with linear, we can totally do it for here too. So x equals 1. So then we're going to do 4 times 1 squared minus 8 times 1. So this is going to be 4 minus 8, which is negative 4. So then my ordered pair is going to be 1, negative 4. And this is also my vertex because it came from this right here of x equals 1. This is also the x value of the vertex. This is also your axis and also axis of symmetry. Okay, so then my vertex is going to be 1, negative 4. So 1, negative 4. And if I was you, I would actually do step number 8 right now. Check it. So it looks like our parabola is going to be opening up based off the 3 points that we've got graphed. Go back up to that first step. Is our parabola supposed to be opening up or down? It's supposed to be opening up. So that means we're headed on the right direction. Okay, so next thing, it says find 2 more points that are near the vertex, but that are not the roots. So if you look, we have used the x value of x equals 0. We've used the x value of x equals 1. And we've used the value of x equals 2. So what's another one we could use? I'm hoping that you say x equals negative 1, for example. So let's put that in. So this is going to be step 5 here. So x equals negative 1. I'm going to do 4 times negative 1 squared minus 8 times negative 1. So here I'm going to get 4 plus an 8, which is going to give me 12. So then I'm going to get negative 1, 12 for that one. So that means I'm going to have to extend my graph just a tiny bit. So negative 1, we're going to call this 11, 12. And then we're going to reflect it over. So when I say reflect it over, what I'm doing is like, I know that my axis of symmetry is right here. I'm counting how many horizontal spaces are in between the point that I just plotted and my axis of symmetry. So I'm going to go over 1, 2, and then I'm going to reflect it over 1, 2. And so my other point is going to be, what is that? 3, 12. So by reflection, and you can write that. You can write by reflection. It's going to be 312. If you would prefer, you are more than welcome to just add another row on here and just plug it in. Do x equals 3. And so you would do 4 times 3 squared minus 8 times 3. And then here we're going to get 36 minus 24, which is going to give us 12 again. So then you would get 312. All right, I'm totally in my graph, and now we're going to graph it. You are going to have to do a much better job than me because this is going to be a little challenging with my stylus and my iPad. All right, so something like that. So do the best you can. Make it a smooth curve. All right, next example. Here we go. We've got y equals negative x squared plus 8x minus 16. So first step, does it open up or does it open down? It's opening down because A is negative 1, which is less than 0. Okay. 2. Now we're going to find our roots. So we're finding our roots, and we're going to have negative x squared plus 8x minus 16, set it equal to 0, and solve for x. So this one, again, is going to be another quadratic formula. We can't do square root property. We could factor it. You could have factored the first one too, by the way, but we're not really working on that method. All right, so a equals negative 1, b equals 8, c equals negative 16. And then it's going to be negative 8 plus or minus the square root of b squared minus 4ac all over 2a. Okay, so now we've got negative 8 plus or minus. Here we're getting 64. We have 3 negatives, so it's going to be a negative here. 16 times 4 is also going to give you 64, and you're going to get negative 2. You should stop right at this moment and say, okay, what does that mean again? What's going to happen when I get a 0 underneath the radical? How many roots am I going to get? Right here. When our 0 is underneath the radical, we're going to get 1 root. And what does that mean about that root? It is also the vertex. Use that to your advantage. So that means here we're going to get negative 8 plus or minus the square root of 0 over negative 2. The square root of 0 is 0, right? So then we're going to get negative 8 plus or minus 0 all over negative 2, which is going to give us negative 8 over negative 2, which is 4. We get one ordered pair, and I need you to write it as an ordered pair. This is our root of 4, 0. Then we're going to go put that down on our graph. 4, 0. So if you wanted to, what's going to happen in step number 3 is that we would be finding the x value of our vertex. Well, if you've already made all those connections that, wait, I have 1 root, that means this is my vertex, you are more than welcome for steps 3 and 4. You could just write steps 3 and 4. 4, 0 is my only root, so it's also my vertex. And you could just write that in there. So you just write that in there for your steps. Because I'm going to go ahead and just follow the steps and follow the process. But if you'd like to skip ahead and try to finish this one out on your own while I'm just continuing talking in the video, do it. So for your 3 and 4, you can write down because, or you could say 4, 0 is also my vertex because it's my only root. And that's your way of telling me that you're understanding what's happening conceptually. All right, I am going to pretend like you don't make that connection. And you're just kind of going through the motions here and you're saying, okay, my vertex, my x value of my vertex, and also my axis of symmetry is going to be negative b over 2a. Or you can come here and look at it right there. There's your negative b over 2a. And so it's going to be negative 8 over 2 times negative 1, which is going to give me negative 8 over negative 2, which gives me 4. So then my axis of symmetry is x equals 4. And so I'm going to come over here and I'm going to do my axis of symmetry. I don't know why my ordered pair keeps getting off here. That should be at 4, 0. And then this is also the x value of your vertex. So plug it into your equation. So this time I'm not going to do the table method. I'm just going to show you another way you can write out your work. So we're going to do x equals 4, and then you're going to plug it in. So you're going to do negative 4 squared plus 8 times 4 minus 16. So then here we're getting negative 16 plus 32 minus 16, and then that's going to end up giving you 0. So this gives you 0, and so then you would be plotting the point for 0. Guess what? We've already plotted that point, so there's really no additional information that we've gotten so far. So now what that means, in step 5, we are going to have to do a little bit more work. So step 5, we've used x equals 4. What's another good x value to use that's close to the vertex? And I would say let's try maybe like x equals 3, and then we're going to try x equals 2. So let's try x equals 3, and then we're going to have negative 3 squared plus 8 times 3, and is it, I think it's just minus 16, right? Yeah. So minus 16. So then here we're getting negative 9 plus 24 minus 16. And you should be getting, I think it's negative 1, right? I want to think about this. Okay. So we should be getting negative 1 for this one. All right, so we're going to graph the point 3, negative 1. So 3, negative 1 here. And then if I was you, I would just go and double check. Like it's looking like it's going to be opening down. Is that correct from our first prediction? Yes, it's going to be opening down. So now the other thing you want to do is reflect that point over. How many horizontal spaces away is 3, negative 1 from the axis of symmetry? And it's 1 horizontal space away. So it's 1, so reflect it over. So the other point that you should be getting, and you need to put a little arrow on here, because this indicates to me that you know what you're doing. It's like our own little secret code. I want you to put an arrow, and then you're going to do 5, negative 1. And that is telling me, that arrow right there is telling me that you found that point by reflection, and you didn't just plug it into your equation. All right, so far we only have 3 points. We've got to do one more point, and then we're going to reflect it over. So far we've used x equals 4, we've used x equals 3, we also have used x equals 5. So let's do like an x equals 2. So now we're going to get negative quantity 2 squared plus 8 times 2 minus 16. So we're going to get negative 4 plus 16 minus 16. The 16s cancel out. You end up with negative 4. So then we're going to get the point 2, negative 4. So 2, negative 4, and then you're going to reflect that over. So it's 1, 2 spaces away, reflect it over, 2 spaces away. So it's going to be 6. Here's my little by reflection arrow. 6, negative 4. Now draw your curve. And we're done with that one. All right. We've got 2 more to try out here. So our next one that I would like for you to try with me is going to be 3, and we've got y equals negative 4x squared plus 4. The other one that we're going to look at is going to be y equals x squared plus 4. And if you want to, you could just pause the video right here and try them out and see how you do, and then play the video when you're getting stuck, or fast forward it to see how your work is matching up to mine. All right, so first step, A is negative, so it's going to be opening down. Number 2, we're looking for roots. So it's going to be negative 4x squared plus 4 equals 0. This one, I'm looking at the fact that we don't have an x to the first, right? We only have x squared. So this is a perfect one to do square root property on. So subtract the 4. And then we're going to have negative 4x squared equals negative 4. Divide both sides by negative 4. And we're going to get x squared equals 1. Take the square root of both sides. And we're going to have x equals plus or minus 1. So write those as ordered pairs. You can't leave them like that. Write them as ordered pairs. It's going to be 1, 0 and negative 1, 0. Now go graph your ordered pairs. So 1, 0 and negative 1, 0. Look, I'm putting them right on the x-axis. Hopefully they stay there this time. 1, 0 and negative 1, 0. So my next step is finding my x value of my vertex and finding the axis of symmetry. So I haven't done that yet. It's going to be negative b over 2a. And if I was you, the other thing you should be doing is predict. Where should it be? See, look, my points came off the x-axis. I'm not happy about that. All right, where should the axis of symmetry be? Like, look where our ordered pairs should have stayed, and where should the axis of symmetry be? Because it should be right in between them. So the prediction is that we should get x equals 0 for our axis of symmetry. So let's find out if that is actually happening. So we are going to get negative b over 2a. I'm going to put this in standard form. So I've got negative 4x squared plus 0x plus 4. So I'm putting that in standard form because I don't have an x. So now my b is 0, right? So it's going to be negative 0 over 2 times negative 4, which is going to be negative 0 over negative 8. And guess what? 0 over any number here is going to be 0. So it happened exactly where we thought it was going to be. So x equals 0 is my axis of symmetry as well as the x value of my vertex. And now we're going to plug that in to our equation. So plug x equals 0 into your equation, and we're going to have negative 4x squared plus 4. And this is going to be 0 plus 4, which is just going to give me 4. And then our ordered pair is going to be 0, 4. So we're going to go graph that, 0, 4. It's going to move on me again, I'm sure. All right. And then step number 5. Step number 5, pick another ordered pair, or pick another x value so we can graph another ordered pair. So we've used x equals negative 1. We've used x equals 0, x equals 1. What's the next one we should use? 2. You could use 2 or negative 2. I'm going to use 2. So now I'm just going to write x equals 2 here. And then I'm going to do negative 4 times 2 squared plus 4, which is going to give me negative 4 times 4 plus 4. 4 is abounding. Negative 16 plus 4, which is going to ultimately give me negative 12. So write your ordered pair. That's 2, negative 12. And then you can do this by reflection, right? So 2, negative 12, I'm going to go 2 and all the way down here to 11, negative 12. And you're counting over how many horizontal spaces away is that point from the axis of symmetry, and it's 1, 2. So count it over, 1, 2. So there we have that. And so by reflection, that's going to end up being negative 2, negative 12, or you could plug it in, totally up to you. All right, draw your parabola as best you can. And then we've got our last example. Ooh, ooh. All right. Step 1, which way? Opening up opening down. Should be opening up. That's a requirement for you to go. Opening up. Step number 2. I'm here for your entertainment, by the way. Step number 2, what are we doing? We're solving for our x-intercepts. So we're setting our equation equal to 0. We're solving for x. Yet again, we've got an x squared and no x term. So let's use that to our advantage and let's use square root property. So we're going to do x squared equals -4. So you're moving that 4 over. Now let's do the square root of both sides. So it's going to be x equals plus or minus 2i, right? So if we were going to graph that, it would be 2i, 0, -2i, 0. Now go and graph that. Wait a second. We can't graph those on our two-dimensional plane. So what does that mean? What conclusion do we need to write in here? The conclusion that you need to write is that we have no x-intercepts. Does that mean we can't graph it? No, it does not. It means we just keep going. So we just don't have any x-intercepts, so you need to draw that conclusion, write it in there, and we just keep going. So now we're going to find our axis of symmetry using this formula. We do not have a b, so it's going to be x squared plus 0x plus 4. So our a equals 1, b equals 0, c equals 4. So we are going to do -0 over 2 times 1, which is going to be -0 over 2, which x equals 0. So our axis of symmetry is going to be at x equals 0. So go plot that in. And then we're going to find the rest of our vertex and some other points. All right, this time I'm going to go back to doing a table. I'm just going to flip-flop. You guys can choose which way you prefer. I'm just showing you both. You can either use a table or you can do it just with the equations like how we did it on examples 2 and 3. So this time we've got x squared plus 4, and then I've got y, and then I've got an ordered pair. I'm doing it in a table for this time because I know I've got several numbers I'm going to have to plug in, and then I'm going to reflect them over. So this is steps 4 and 5. So here's my vertex in this one. So this is really my step 4 right here. So x equals 0. It's going to be 0 squared plus 4. That's going to give me 4. My ordered pair is going to be 0, 4. So let me go plop that in there. And see, it moved again. Irritating. All right, so there's my step 4. Step 5 is coming right here. So let's just, I'm going to try x equals 1. So x squared plus 4, which is going to give me 1 plus 4, which is going to give me 5. And I'm going to get 1, 5. And then I'm going to reflect that. So it's going to be 1, 5 right here. Of course, it's going to move on me again. So you're going to reflect it over. So it's 1 horizontal space away. So reflect it over, and it's going to be -1, 5. So I'm kind of out of space here, but I would normally do a little arrow like that, and then I would do next to it -1, 5. And we're going to do another one. So I'm going to go ahead and do 2. And it's going to be 2 squared plus 4. So it's going to be 4 plus 4, which gives me 8. And then I'm going to have 2, 8. So 2 on up here to 8, reflected over. So it's going to be 1, 2, 1, 2. So we're going to have -2, 8. And now we've got at least 5 points. So now graph it. Okay, that is the end of this video. Thanks for tuning in, guys.